Welcome to this video from LearnElectrics about finding shorts. This is part 1 of the story and deals with shorts between live conductors and how to quickly home in on them. There was far too much to put into this video to include the earth fault part of shorts, so earth faults will be in the next one, the part 2 follow-up video, and then part 3 will be a video specific to radial circuits. Enjoy. To begin, what is a short circuit? We need to understand the terminology first. If we are being pedantic and following the naming convention, then words matter. Not everything is a short circuit, so let me explain. A short circuit is a low impedance path or connection between two live conductors, a nail, for example, across the conductors. That is to say, between line and neutral, line and line, phase and neutral, and phase to phase. Notice that there is no mention of earth or CPC. An earth fault or ground fault is a low impedance fault or path between a line or phase conductor and the earth or ground conductor. So that would be line to earth or phase to earth. And there is a difference. Before we do any testing, we must always check that our meter is working correctly and that the leads are in good order. Link the crocodile clips together and on the low ohms setting you should get 0 ohms, showing that the leads are in the correct holes and are continuous. Then open the croc clips so that the red and black are totally separate. This shows you the meter's maximum reading, the open circuit reading. Every meter is different. If your meter can be nulled or zeroed, do this too. Or remember the offset and deduct this from the readings that you make. Starting with a no-fault scenario, we have two conductors and there is nothing wrong with the circuit. A low ohms measurement between these two separate conductors should return a high resistance reading, the meter maximum. OL shown here out of limits. Your meter might show 199 ohms, 1999 ohms, or even 9999 ohms. We would call the reading shown here an open circuit. There is no route for electricity between the conductors under test. This is a good reading. This is what we want the meter to read between the two separate wires, no connection. So how will a short circuit show up? With both ends of both wires in free air, we can test between the brown and the blue. We know that we have a fault in this example, a huge nail piercing both insulations, and the meter shows this as 0 ohms when we were expecting OL or a meter maximum. Confirmation that something is wrong. More often, a small reading will be shown, the resistance of the copper in the circuit, and we can use this number to help us to locate the short. This is still called a short circuit, and it is only time and practice that teaches you how to know when you are looking at a problem. We can use the resistance tables in the books to calculate an approximate distance to the problem that is causing the short circuit, and we will do this shortly. A typical short circuit might be damaged insulation that is exposing the copper conductor on both line and neutral, and they are touching each other. This is a short circuit. It is a low resistance path between copper conductors. Correctly named, they are both live conductors. One is called line and the other is called neutral. An earth fault, however, is damaged insulation that is exposing copper conductors on both the line and the CPC or earth. Again, there is contact, a low resistance path between both copper conductors. Another earth fault favourite is where the insulation is torn on the metal edge of a galvanised back box, no rubber grommets fitted. The line conductor is making direct contact with earthed metalwork. A low resistance path and earth fault, not a short, because it involves earthed metalwork. Let's just recap on that for a better understanding. A short circuit is between live conductors and an earth fault is between a line or phase conductor and earth. As far as the customer is concerned, the result is the same, and if the circuit has been designed and installed correctly, the fuse will blow, the breaker will trip, or the RCD will operate. Here are some examples of short circuits, and there are many variations. Shown here is a short in a three-phase system between L3 and neutral, or you may call it phase 3 and neutral, in fact any phase to neutral, or in a three-phase system between any two phases, shown here as L1 and L2, brown to black. Now we have an earth fault, in this case L3 to earth or CPC. Neutral and earth are the same point electrically back at the intake position, but we can have a neutral to earth fault if the problem, the connection, is in some other part of the circuit where it shouldn't be. There are also some self-inflicted problems that you should be aware of, and this one is quite common. Shown here is a correctly wired 3-plate ceiling rose. The switched line should be in the switch block as shown here. And now the incorrect wiring. The switched line has been put into the neutral block to match the colours, brown to brown, blue to blue, etc. This is usually done by a householder after decorating or trying to change light fittings. All the browns together, all the blues together. Simple. Wrong. The first thing to decide is, do I have a problem, and if so, what type of problem? Let's look. We will make an assumption for this video that it is the breaker that is constantly tripping and not the RCD. Ask the customer if they've had any work done recently, and this sometimes gives a clue to where to look first. After that, the most efficient way to look for shorts is to turn the circuit breaker off for that circuit, remove all the loads on the circuit, all the plugs, lamps, FCU fuses, etc., and put all the light switches to a known off position, and then, with all the loads removed from the circuit, turn the breaker back on. Does it trip? If the breaker does not trip, turn the light switches on one at a time and wait a few seconds before turning the next light on. Turn each load on one at a time. Replace the fuses in the FCUs and energise the load. If a particular load or light causes the tripping, this may give a clue to where we should test first. Safe isolation of a circuit is something that should never be skipped or bypassed. We have a video on safe isolation procedure, and we've left a link in the description to this video. Always remember that if the circuit is not dead, then you might be when you touch it. The next step is to safely isolate and lock off the circuit under test, or turn off the whole board if required. After proving safe isolation, then, at the consumer unit, remove the line, neutral and CPC conductors for that circuit. With the conductors removed from their connections in free air, we have effectively isolated the circuit for the duration of the tests. In this video, we're only looking at shorts between line and neutral. Finding earth faults is in the part 2 follow-up video. Now we must establish that line and neutral are both individually continuous before looking for the short. Any short should make no difference to this test. This is a ring circuit, so all the connections will be at the consumer unit. Shown here, we've measured L1 to L2, an end-to-end test, at the consumer unit, and have a reading of 0.185 ohms. Now low ohms measure between N1 and N2, and we should see very similar readings. It's the same size copper going to almost the same points on the circuit, so should be almost the same. It helps to imagine that the ring circuit is now one long continuous radial circuit with sockets. We are going to test just between L1 and N1, or just between L2 and N2, whichever is more appropriate. In this example, the sockets are evenly spaced 5 meters apart, and we know that there is a short between line and neutral somewhere. Let's find it. We will look at two methods of finding the fault, and this is method number 1, where we will calculate the distance from the consumer unit to the point of the short. We've established that we have a line and neutral short circuit from our previous tests. A measurement between line and neutral returns 0.17 ohms when we should have OL, or open circuit. Now we can use the tables in the on-site guide or in guidance note 3 to determine the length or distance from the test meter crocodile clips, and this is a very easy calculation. This is the table that we need to refer to. As this is line and neutral, both conductors are the same size, that is 2.5 square millimeters. Find 2.5 and 2.5 in the first two columns. Ignore the heading for protective conductor. Any conductor will be the same. We just need to match the cable sizes. The third column tells us that two 2.5 square millimeter conductors will have a combined resistance up one and back down the other of 14.82 milliohms per meter length. The standard formula for resistance is shown here, and I've rearranged this to allow us to calculate the length if we know the total resistance, which we do, 0.17 ohms. The number 1000 is used to convert the answer from milliohms into ohms. Let's look at this in action. The length or distance to the short circuit will be 1000 multiplied by the test meter reading, 0.17 here, and then divided by the milliohms per meter value of the two conductors, 14.82. Pop these into a calculator and we have an answer of 11.47 meters. The problem is going to be about 11.5 meters from the crocodile clips, or the consumer unit in this case, whichever the test point is. Remember, 0.17 ohms is the resistance along the line conductor to the point of the short and back again on the neutral conductor, and the tables take account of this. Moving on to method number 2, which is useful if you're not sure of cable lengths between sockets. In this method, we will link cables and home in on the short circuit. Using the same concept as before, and remembering that this ring circuit is now imagined as one long radial circuit, we must ensure the safe isolation has been carried out and that the circuit conductors are removed from the circuit breaker, neutral bar and earth bar. We will be linking line and neutral together. This must be carried out on a known dead circuit. If the power is on and the conductors are still in the breaker or neutral bar, then you will get a bang, a loud one. Safe isolation is a must. Even though I might have isolated, I will still test every socket for dead with my meter before I put the shorting link anywhere near it. And some electricians put a piece of insulating tape on each socket with a socket number or letter to show that they've tested it for dead, a visual confirmation. No tape, don't put the link in. I do this test using a socket test adapter to make the link between the line and neutral on a dead circuit. And do remember to put the switch into the on position, otherwise you will not get valid results. Start by linking the socket nearest to the consumer unit, socket A here. The link will be between line and neutral. In this example, we have a reading of 0.074 ohms. Write it down. Please don't trust it to memory. Personally, I like to make a rough drawing of the circuit and mark the values on it as I test, and I find it really helps. Now move to the next socket, marked as socket B, and we have a reading of 0.148 ohms. The readings are changing from A to B because we've put the link in before the location of the short. The link is nulling out almost all of the effects of the short circuit. Moving on to socket C, we again put the link in between the line and neutral, ensuring that the switch is in the on position. The reading is now 0.17 ohms, a very slight increase from the previous test, but we cannot be certain yet. B and C might be very close together. Now move to socket D, put the link in and test again, and we get the same reading, 0.17 ohms. The short circuit is holding the resistance at 0.17 ohms. We are now on the other side of the short, and this is preventing the test readings from changing. Any measurement after the short will return the same reading. The reading at B was 0.148 ohms, and everything after is 0.17 ohms. We've shown the short here a great big nail, so that the next part is easier to follow. The readings tell us that the short should be between socket B, the last known normal reading, and socket D, the second socket where we have the same repeated reading. To prove this, remove the conductors from socket C and test again. First, between L1 and N1, and the meter will show 0.17 ohms, as the test signal can only get as far as the nail. Now measure between L2 and N2, the other two ends of the ring circuit that are at the consumer unit. Because we've broken the circuit at socket C, there is no continuity from L2 and N2. It is open circuit and the meter will return OL. So, from L1 N1 to socket B is OK, and from L2 N2 to socket C is OK. The short must be between sockets B and C, and that should reduce your search time quite substantially. A quick recap on naming conventions. It matters in assessments, and some of what we've done here may be asked of you in practical assessments. A short circuit is the low resistance path between the line conductor and neutral, or between line and line in a three-phase system, whereas an earth fault is a low resistance path between the line conductor and a CPC or earth conductor, or some earthed metalwork. In common parlance, the word short is used for both a short circuit between two live conductors and an earth fault. This is incorrect, but it's what happens, and it will be difficult to get all the world to call them by their proper names. This video is about finding short circuits in the live conductors. Finding earth faults is in a follow-up video, as these require a little more testing. Thank you for watching. It really is appreciated, and I hope that you found this video useful and informative. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And you will find even more information, videos and help on our website at LearnElectrics.com. And don't forget, you can also type in LearnElectrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel, so don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.